Welcome to a lesson on constructing a perpendicular bisector of a segment using Geometer Sketchpad. So we'll start by constructing a segment. So we can use this tool here, hold down the cursor, select this first option, then we can click and make a segment on the screen. I'm going to go ahead and make this thick, so I'm going to right click, select thick, and we'll keep the color the same. Now I'm going to go up here and click on the selection tool, and then click anywhere in the white to unselect the segment. Now normally what we do is we swing an arc above and below the segment using a compass with the point at one endpoint, and then do the same at the other endpoint. But in Geometer Sketchpad we'll have to construct two congruent circles with the center at each endpoint. Let's go ahead and select the circle tool. And again, the only restriction here is that when we construct our circle, we'll click here at one endpoint and then drag to make our circle. The radius of the circle must reach past the midpoint of the segment so that the two circles will intersect. So maybe somewhere in here. Now to make a congruent circle, we'll have to measure the radius of this circle, and we can do that by going up to Measure and then select to Measure and then select Radius. I'm going to click on the selection tool, click on this measurement, and I'll just move it over here to the right side. Now with the radius selected here, we're going to click on the other endpoint, and then we can go up to Construct and select Circle by Center plus Radius. And now we have two congruent circles with their centers at the endpoints of the segment. Now we need to determine the intersection of the two circles, so notice how this first circle is already selected. Now we'll select the second circle, go up to Construct, and then select Intersections. And so the perpendicular bisector will pass through these 2 points of intersection. And again, notice how the points of intersections are already selected for us because we selected the intersection option. So now we can go up to Construct and select Line. Let's go ahead and change the color so it stands out. Let's go ahead and change the color to red, and then we'll click anywhere in the white region to unselect the perpendicular bisector. Remember, this perpendicular bisector bisects the blue segment, and there's also a perpendicular to the blue segment. And let's go ahead and verify that. Let's go ahead and select the blue segment and the red perpendicular bisector, and then click on Construct Intersection. Let's go ahead and unselect everything by clicking in the white. Let's first verify that the perpendicular bisector does bisect the given segment. So we'll click on one endpoint and then click on the point of intersection, and then we'll go up to Measure and then select Distance. So the segment AC has a length of 4.89 centimeters. Let's unselect this by clicking in the white. Now we'll measure the length of the other segment from the intersection point to the other endpoint. So we'll select those 2 points and again select Measure, Distance. And we can see that they're the same measure. Let's go ahead and unselect this by clicking in the white. Actually, let's go ahead and select both of these at the same time, and let's move these down to the left. And then unselect them. Now let's go ahead and verify that we have two right angles. We measure an angle by selecting 3 points where the middle point would be at the vertex of the angle. So we'll go ahead and select 1, 2, 3 points. Go ahead and measure the angle. Select Measure and then Angle. It's down here, let's move it up. Notice it's 90 degrees. This is enough to verify that these are perpendicular. Let's go ahead and measure angle ACE. So we'll unselect, select point ACE, measure, angle, and move this up, and you can see that that angle is 90 degrees as well. I'm going to go ahead and unselect these now, and I'm going to go ahead and change the length of this segment, and you'll see that regardless of the length of the segment, this red line is the perpendicular bisector. And that's going to do it for this video. I hope you found this helpful.